Okay, in example number 8, we're going to use the definition of Descartes' rule of signs. According to Descartes' rule of signs, if we let f of x equal that polynomial be a polynomial function with real coefficients, the number of positive real zeros is either equal to the number of sign changes of f of x or is less than the number of sign changes by an even integer. The number of negative real zeros is either equal to the number of sign changes of f of negative x or is less than the number of sign changes by an even integer. So example number 8, we're going to use Descartes' rule of signs to determine the possible numbers of positive and negative real zeros for this function. So by determining the number of sign changes, if we look at the function f of x, we go from negative x to the fourth to a negative 3x cubed. So the sign doesn't change there, but it changes from negative 3x cubed to plus 6x squared. So therefore that's one sign change. Now going from plus 6x squared to minus 4x, again, that is our second change. And then from negative 4x to minus 12, there isn't a sign change. So there are two sign changes. So there are either 2 or 0 positive real roots. Next, we have to examine f of negative x to determine the number of negative real roots. So we got to plug in negative x for each value of x and then simplify. So if we plug in negative x to the fourth power, it still stays positive, so you have negative x to the fourth. You have negative x cubed, which becomes negative x cubed times negative 3, which is plus 3x cubed. Plugging in negative x and squaring it makes it positive, so that remains plus 6x squared. Putting in negative x, multiplying it by negative 4 gives you plus 4x, and then we have minus 12. So now we can now determine what are the sign changes. So it changes from negative x to the fourth plus 3x cubed. So we have one sign change there. It doesn't change in the next one. It doesn't change with 6x squared plus 4x, but it changes from plus 4x to minus 12. So there is our second change. So again, there are two sign changes. So there are either 2 or 0 negative real roots. Now there are 4 possibilities, as we can see in table 1. For the positive real zeros, we have 2. We have negative real zeros, 2. Complex zeros, 0. Total zeros, 4. This is one scenario. Our second scenario would be that we have 2 positive real zeros, 2 complex zeros, meaning 4 total zeros. 3. We could possibly have 0 positive real zeros, 2 negative real zeros, 2 complex zeros, which totals to 4. And then our fourth scenario would be that we have 0 positive real zeros, 0 negative real zeros, but we could have 4 complex zeros, which totals to 4. And the reason why it has to total 4 every single time is because that is the degree of the polynomial. So we can confirm the numbers of positive and negative real roots by examining a graph of the function. So let's take a look at figure 5. Okay, we can see from the graph that the function has 0 positive real roots and 2 negative real roots. So you have 2 negative real roots.